Hey there, so today's Leetcoding challenge question, it's called flat fill. So what we have here is an image represented by a 2D array of integers. It's a two-dimensional matrix, and the integer represents the pixel value of the image from 0 to 65,535. That's 2 to the 16, so it's 16-bit integers, I guess. And presumably it's the grayscale, black and white image, because we only have one channel. What we want to do is to, given a starting pixel represented by the row number and column number, we want to perform a flat fill. So it's basically changing the connected cells, connected locations in the picture that's of the same color with this new color. So we start from the starting pixel, and we can move in 4 directional, up and down, left and right, whenever we can. So for all those reachable locations with the same color as the starting pixel, we change them into the new color, and we return the image after modification. As an example, we have this input image represented by this array of arrays. Just do a little bit rearranging to make it looks like an actual picture. We have the row number and column number to be 1, 1. The new color is 2. So the first thing we check is the first thing we do is actually to grab the old color so that we can do a comparison, because once we start to change the colors, we will lose that. So the old color is going to be the row index 1 and column index 1. That's the middle one there. So the old color is 1. So when we do the explorations about the adjacent cells inside this 2D matrix, whenever we see a reachable 1, we can change that value into 2. So it depends on how we do this exploration. If we do BFS, it will be something like this. We change the starting pixel to be 2. We move in 4 directions. We change the upper to be 2. We change the left to be 2. And then we then change the reachable stuff from the top, the left and right from the top to be 2, and then we go back to this left 2. The upper one already been changed, so we modified the one that's under it. And after that, we run out of the cells that we can actually go to. So that's when we terminate. Yeah, so the one that's just illustrated here is the BFS kind of strategy. If it's a DFS, it will be, let's say that we change it back to 1 using DFS. It could be 1, 1, 1, then backtrack, go the other direction, then backtrack, go towards left, and then change the very last one there. So this is illustrated as DFS. There's really no difference in this case because we have to explore all the connected components, and we have to visit every cell at least once. So either BFS or DFS, there's no shortest pass kind of situation. We don't have early stopping, so using the two are equivalent. And in terms of time and space analysis, the space is going to be the same size of the matrix. If we have to, if the whole image is in the worst case, if the whole image is just one single color, then doing the flat fill, we have to change everything. So the time and space will be order of number of values in the 2D matrix. So that's the time and space. So that's pretty much it. It's a relatively straightforward question. So let's just start coding. We grab the number of rows and number of columns. Do we have any edge case? It doesn't really mention. Oh, it says it has to be at least 1 pixel. So yeah, just grab that. We don't need to handle the case when it's empty. And then we keep track of the old color, which is the image source row source column. That's going to be the criteria we check to actually perform the color changing during the exploration. So then we're going to have a deck which contains the locations, which is a tuple of two row number and column numbers. So it's integer. We call this toColor. That means the cells we need to explore and do the color changing, or toFill. And initially we will just have the source row and source column in there. And what we're gonna do is to, while we still have something to do, some work to do, meaning that this deck is not empty, we're gonna grab the cell value. So that's the location is gonna be the, if we do BFS, it will be front, and we're gonna pop that out. Then we can unpack this to be the row number and column number. What we need to do is to change the color for that. One thing that we can actually terminate early on is if the old color is the new color, then there is no change that is needed whatsoever. Just add one line here. So that's handle that special case. So just to make a quick comment here, we're doing BFS. This is the row number and column number. What we need to do is to actually do the color changing. Image row and column. We'll set the color to be the new color. Then we're gonna do the directional move. So if we can move up, that's if the row number -1, it's greater than or equal to 0. And the cell that's above us is the color that we can, it's the same as the old color. Then we're gonna just push that the location onto the deck. So that's move up. Then we just basically make duplications. We want to go down as well. So that's the condition now becomes we are now out of we exiting the total number of rows by moving down. Then also the cell that's directly below us is the old color. Then we can move there and actually do the color changing and keep exploring from there as well. And then we deal with the move right and left, which is equivalent to column subtract 1 and column +1. The rows are going to be the same. And the condition for moving towards right is that the new column number has to be less than the total column number. And yeah, just making a few small changes, we should be good. And in the end, we have to return the modified image. So that's pretty much it. Let me run through some examples. Yeah, this one looks okay. Just quickly check if I have obvious problems. I don't think so. So yeah, so that's pretty much the solution. Let me submit it. Yeah, it's working. I guess a little bit organized can be done is to consolidate this for line to maybe put the 4 movements into some kind of array, because it's pretty much the -1 0 +1 0 0 -1 0 +1 by moving the deltas according to the rows and columns, and so that this can be a little bit nicer, but I personally think this is fine too. So yeah, that's the question.